Welcome everybody. So what we want to do is go through a practice homework 5. Again, you've been asked to study Lewis structures and VSEPR theory in the lectures, lecture quizzes, as well as in class, but hopefully this one last practice will help you complete homework 5. So the first thing that we want to do is the math here for our Lewis structures. And so start with the formula. So here I have CS2, which means I have a carbon and two sulfurs. And so you want to calculate the valence electrons and the octet number. Remember that valence electrons is equal to group number, and that the octet number is 8 for everything except for hydrogen. And so carbon's in group 4, sulfur's in group 6. So I've got 16 electrons to work with. Each of those would like to have 8 electrons, and so my octet number is 24. Subtract those two, 24 minus 16, that's going to give me a deficit of 8 electrons. Remember, that means 4 bonds, 2 electrons per line. Subtract the number of bonding electrons from valence electrons, it's going to give me 8 non-bonding electrons, which is 4 lone pairs. Remember, this is where your dots are going to come in. And then whatever's listed first goes in the middle. So I've got to put my carbon in the middle, and I've got to bond 2 sulfurs to it. Right? That takes care of my formula. The next thing I want to look at is bonds. Right now I only have 2 bonds. I need 4. So I need to add 2 more bonds. So I could add them 1 on each side. I could add them both to the left. I could add them both to the right. It doesn't matter. They are all acceptable. And so I like to be symmetrical, so I'm going to put them on both sides. So now I have my 4 bonds. And now I add my lone pair so that everything has 4 pairs around it. So right now, the sulfur both have 2 bonds, which means they need 2 lone pairs. The carbon has 4 bonds, so it's done. So again, every atom should have around it a combination of 4 bonds and lone pairs. So there are my 4 lone pairs. Everything has an octet. That is a great Lewis structure for CS2. Now let's look at NH2Cl. So again, I'm going to write down my formula. I've got a nitrogen, hydrogens. And so again, when you see hydrogens, you got to have alarm bells going off. And so hydrogen is going to affect the octet number. So again, nitrogen's in group 5, hydrogen's in group 1, chlorine's in group 7, so nothing funny about the valence electrons, just use the group number. So I've got 14. But the difference is why nitrogen and chlorine want 8 electrons like everything else. Hydrogen is different. Hydrogen only wants 2. And so my octet number here is 20. So I take the difference, right? The octet number tells me how many electrons short I am. I'm 6 electrons short. So I'm going to share 6 electrons as bonding electrons, which is going to give me 3 bonds. Out of my 14 electrons, 6 are bonding. The other 8 are non-bonding, so I'm going to need 4 lone pairs. So again, I put my nitrogen in the middle. It's listed first. Based on my formula, I got to bond 2 hydrogens and a chlorine to my nitrogen. So that's my formula. That also accounts for my 3 bonds. So now I just have to add my lone pairs. Never add lone pairs to hydrogen. So my nitrogen's got 3 bonds, it needs 1 lone pair. My chlorine's got 1 bond, it needs 3 lone pairs. So there's my 4 lone pairs. Everything has what it wants. Again, hydrogen, different than everything else. It makes 1 bond and only 1 bond, that's all it does. Because remember, hydrogen starts off with 1 electron. The only thing it can do is share that one electron. All right, let's move on to our next molecule. And so here we have NO2, and this is the first time that we have a charge. And so we have a positive charge. And so charge is going to affect the valence electrons. So nitrogen's in group 5, oxygen's in group 6. A positive charge means you've lost an electron. Don't forget it's the opposite. And so my number here is 16. Also be careful when you do your octet number, right? The nitrogen, the oxygen 1, 8. The charge doesn't affect octet number. And so my number here is 24. And so I'll have 8, 4, 8, 4. Same as what I had up above. And so when I go to draw my structure, nitrogen goes in the middle. Formula says I've got 2 oxygens bonded to it. And then if you have a charge, go ahead and put brackets around it and put the charge on the outside and let everybody know that this structure has 1 less electron than it should if it was neutral. So there's my formula taken care of. Now I need to worry about bonds. So again, I could put 1 on each side, or I need 2 more bonds. Let's put them both on the left this time. Again, you could go with the same thing as up above, but I just want you to realize it doesn't matter. They're both acceptable. So here, if I do it this way, the oxygen on the left has 3 bonds, so it only needs 1 lone pair. The nitrogen in the middle has its 4 bonds, it's done. And then the oxygen on the right has 1 bond, so it needs 3 lone pairs. Again, if you drew something with a double bond on both sides, you would put 2 lone pairs on each oxygen. Both of those are acceptable. They match up with your numbers, they give everything an octet. So again, we got 4 bonds, we got 4 lone pairs, everything has an octet. All right, let's move on to our last example, which is our hydrogen. Alarm bells. So we've got our hydrogen, we've got a carbon, we've got 2 oxygens, and then we have a negative charge. And so in terms of valence electrons, hydrogen's in group 1, carbon's in group 4, oxygen's in group 6, we got 2 of those. A negative charge means we have an extra electron. And so here I've got 18 electrons. Now when it comes to the octet, again, hydrogen starts off with 1, but it only wants 2. It wants to go from group 1 to look like helium. Everything else always wants 8. Hydrogen's the only exception that we're dealing with. And so I've got 3 atoms, a carbon and 2 hydrogens, 2 oxygens that want 8. My hydrogen that wants 2, so my octet number here is 26. So I have 18 electrons to work with. I need 26, so I have a deficit of 8, so I'm going to need 4 bonds here. Out of my 18 electrons originally, 8 are involved in bonding, the other 10 are non-bonding. I'm going to have 5 lone pairs. So when I start to build this, hydrogen can't go in the middle because it makes 1 bond and only 1 bond. My carbon goes in the middle, and then based on the formula, it's bonded to a hydrogen and 2 oxygens. And again, that all has a negative charge. So there's my formula taken care of. Now, when it comes to bonds, I need a second bond. So I could put it here. I could put it here. I cannot put it here. No, 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 no. Right? Because again, hydrogen makes 1 bond and only 1 bond. So I'm going to put my double bond over here on the left. Now, I need 5 lone pairs. Carbon's got its 4 bonds. The hydrogen never gets lone pairs, so this oxygen with 2 bonds needs 2 lone pairs. This oxygen with 1 bond needs 3 lone pairs. So there's my 5 lone pairs. Everything's got the proper number of electrons. There are my Lewis structures. All right, let's look down at the bottom. Again, I think when you want to go count reds, which is sides occupied. And so if I'm looking at this one, that's 4 reds. That's a tetrahedral geometry. Here I've got left, right, bottom, and nothing on the top. That's 3 reds. That's trigonal planar. Here I've got left, right, lone pairs count. So this is 4 reds. All 4 sides have some sort of electrons on them. So this is also tetrahedral. And then my last molecule, just the left and right, nothing on top and bottom. So there's only 2 reds here. So this is linear. So that's how we deal with electron geometry. Let's talk about molecular geometry. If there's no lone pairs on the central atom, they're the same. So this is tetrahedral, tetrahedral. This has no lone pairs. So this is trigonal planar, trigonal planar. This one down here has no lone pairs. So this is linear, linear. Here, I have lone pairs. So when you go to your geometry, your molecular geometry table, 2 atoms, right? This has 2 atoms. And yes, for lone pairs, this is what we call bent. And then finally for polarity, right? Anything with dots on the central atom is polar. Here, right, your phosphorus is bonded to chlorine and oxygen, right? Notice that there's oxygen here, chlorine here, so that means that it's polar. Same thing for this one. My nitrogen is bonded to O and Br. Right, there's the bromine, there's the oxygen, and so when the central atom is bonded to more than one type of element, we get polar. The only one that's nonpolar is D, right? No lone pairs, and the carbon is only bonded to sulfur. So again, I know that you've practiced all these skills with your exercises and lecture quizzes and in class, so hopefully you're feeling really confident about this, and so you can do a good job on homework 5. As always, thank you for your time.